Good morning. My name is Pat Alitgatana, and today we're going to be doing this question. Here we have a sequence, un, where the first term is 1, and the recurrence, un plus 1 equals the square root un plus 1 over square root 3 minus un for all n is bigger or equals to 1. What we're supposed to do is finding the second term, third, fourth, fifth, and sixth term. Okay, first we're starting with laying this out. So we have un plus 1 equals to square root 3 un plus 1 over this. Now let's just factor out square root 3, see what we can find, just for the sake of doing it. And then we have this. Okay, so looking at this might be a little familiar because it resembles the trigonometric formula that I will be writing here. Yeah, so this and this have the exact same structure. What we want to do is revert this into a smaller form so it's easier to understand. So if we convert this, we'll get un will be tan of wn being something that refers to n and changing. Then we have tan pi over 6. This, we just plug these two in, so now we have this. What we want to do is change this into this form so it's much easier to deal with. Nice, okay. So now that we have this, we can easily find the terms. First, we have u1, which we know is 1. Now, u2, if we plug that in here, that will cause this arc tan of u1 plus pi over 6. What's going to come out of this is tan pi over 4 plus pi over 6, which should be tan 5 pi over 12. All right, so we're going to do this for everything else. u3 is going to be tan. And arctan of u2 will just get rid of this. So we'll have this plugged in already. 5 pi over 12 plus pi over 6, which is tan 7 pi over 12. Now, if we revert this to its form of tan pi over 4, you would actually notice that there's a pattern here. Changing the denominator to 12 will show you that in here, in the brackets, we're just adding pi over 6 over and over again. So, you don't have to do all the math anymore. Now, you know that this will be 9 pi over 12. And you know this will be 11 pi over 12. And you know the last term will be 13 pi over 12, which we know to be pi over 12. Now that we have all this, we can go to the next part of the question, which is finding the sigma of this sequence from 1 to 2024. So, there's a reason why we have had to find from the first until the sixth term. What you want to do is figure out the sum of all terms from 1 to 2024. But if we can figure out a pattern, we can cut that down to size and make it much easier. If you go to U7, you'll find that what is done is it reverts back to the start. So this would be 3 pi over 12, then it's just going to be 1 as such. So all this from U1 until U6 is a pattern that will keep re-emerging until 2024. So we want to figure out the sum of these 6 terms, then we can figure this one out. If we take this, which is 1, and then if we look at, actually if we look at these two, let's look at these two first, okay? There's a rule here where tan pi minus alpha equals tan alpha. You all know that. So this would be minus tan 7 pi over 12. That means this is the direct opposite of this, and you can cross both of these out. Then if you look at this and this would be minus 1, this would be plus 1. So these two are taken out. And these two also do the same thing. So these two cancel out. Now we realize that the sum of all 6 of these terms is 0. So if we turn this into the sum of all of them, we would have 0 times 2024 divided by 6. That would be 337 plus 2. The 2 is not actually a part of that, but these will be the next 2 terms that come up, which are U1 and U2. So now we replace this with tan pi over 4, which is just 1, then tan 5 pi over 12. Right. So now we have 1 plus. This is going to be hard to figure out, but if you look at it again, you realize you can actually revert it to the same form as this because we have these 2. So what we're going to do is have this equals to tan. You can break that down to this, right? So we have this plus tan pi over 6 over 1 minus tan pi over 4 tan pi over 6. Nice, okay. Now we're just going to continue this. You know the drill. This is just that. That is just. And if you plus this all together, you're going to figure this to its bigger form. So it's much easier to do. There we go. We can just erase the 3 here. We have 1 plus 3 plus square root 3 over 3 minus square root 3. We can use the a squared minus b squared rule, which will give us. Oh, actually, we can just modify this. And this will go into. Now, we can just expand this outward. We have 9 plus 6 square root 3 plus 3 over 6. Now, this will turn out to be 2 plus square root 3. The answer is 3 plus square root 3.